Today's story begins at Stockholm Arlanda Airport, Sweden, where a McDonnell Douglas MD-81 of Scandinavian Airlines, nicknamed Dana Viking, landed on the night of December 26, 1991, after an uneventful flight from Zurich, Switzerland. Despite the bad weather, the journey went smoothly, and once the last passengers disembarked, the aircraft was secured for the night at around 11 p.m. That night, the airport was wrapped in inhospitable but not extreme weather. The temperature was around 1 degree Celsius, and a light drizzle fell persistently, never turning into snow. For the passengers of that flight, it was a typical Swedish winter night, wet and cold. However, without anyone suspecting it, those conditions were the first link in what was about to unfold. December 27, 1991, Arlanda International Airport, Stockholm, Sweden. Here, Scandinavian Airlines Flight 751 waits to depart for Barcelona, Spain, with 2 intermediate stops in Denmark and Poland. Founded in 1946 through the merger of 3 smaller airlines, Scandinavian Airlines System, better known by its acronym SS, is the joint flag carrier of Denmark, Norway and Sweden, bringing air travel in the 3 Nordic countries together under the banner of international cooperation. At 7:30 a.m., with the temperature still hovering around 0 degrees Celsius, preparations began for Dana Viking's next journey, the flight to its first stop in Copenhagen, Denmark. 6 crew members had been assigned to the flight, including 4 flight attendants and a 2-pilot crew consisting of Captain Stefan Rasmussen, 44, and First Officer Ulf Cedermark, 34, who had a combined total of 11,000 flight hours. Neither had extensive experience with the MD-81, though Captain Rasmussen's 600 hours on the aircraft far surpassed First Officer Cedermark's total of just 76. In addition, 123 passengers were also on board, bringing the total number of people aboard the MD-81 to 129. As the passengers prepared to board the plane, ground crews inspected the wings for ice and snow. Using a ladder, a mechanic leaned over the leading edge of the wing and scraped away the slush, finding no ice formations. Meanwhile, Captain Rasmussen ordered the aircraft's fuel tanks to be refilled and then turned his attention to de-icing. A mechanic had reported frost on the underside of the wings and wanted it removed, as it could negatively impact the plane's aerodynamics. As a result, Rasmussen ordered the aircraft to be de-iced, and ground crews sprayed the wings with a heated glycol and water solution. When the mechanic reported that the de-icing was complete, Rasmussen double-checked and asked, "Is it nice and clean under the wings now?" "Yes, there was a lot of ice and snow down there, but now it's good. Now it's perfect," the mechanic replied. Flight 751 was now ready for takeoff. At 8:47 a.m., the aircraft began taxiing down the runway. It lifted off without issue and began its climb toward Denmark. But the illusion of normalcy didn't last long. As the plane took off and began its ascent, the weight shifted from the landing gear to the wings, causing them to flex up and down. This movement broke a layer of invisible ice on the wing surfaces that none of the maintenance technicians had noticed. The ice detached from the wings and slid backward into the slipstream, directly into the MD-81's 2 engines. Large chunks of ice struck the rapidly spinning fan blades, causing powerful impacts that damaged several blades in both engines. The smooth flow of air over the fan blades is critical for maintaining stability in the entire compression and combustion process. Although none of the blades broke completely, the deformations caused by the ice were enough to disrupt the delicate balance of pressures inside the right engine. "25 seconds after takeoff, a deep, muffled sound was heard, followed by an explosion. Immediately after, 2 more explosions followed in quick succession. Meanwhile, the plane continued climbing and accelerating. The captain attempted to engage the autopilot, as he normally would at this stage of ascent, but it failed to activate. An alarm sounded in the cockpit, indicating that autopilot engagement was not possible at the moment. The crew still didn't know what was happening at the rear of the plane. Captain Rasmussen then looked at his instruments to identify the source of the problem. Although he struggled to read the digital indicators due to the severe vibrations and wildly fluctuating readings, he realized the issue was with the right engine. He immediately reduced its power slightly. Reducing power is an effective response to a compressor stall because it decreases the pressure in the combustion chamber. However, the required reduction can vary, which is why the official procedure mandates that the pilot move the affected throttle lever to idle. Instead, the captain only reduced power by 10%, which was insufficient to prevent the engine from continuing to experience compressor stalls. The McDonnell Douglas MD-80 is equipped with a system called ARTS, Automatic Reserve Thrust System, designed to ensure that if an engine fails after takeoff, the other automatically increases its power to the maximum permitted level. This is crucial because, with reduced power, the aircraft might not generate enough thrust to climb safely. The ART system activates when there is a 30.2% difference in rotational speed between the 2 engines. However, the FAA identified a limitation in this system. Some airlines reduced engine power after takeoff to decrease noise, which left the aircraft with less thrust than expected in the event of an engine failure. To address this, McDonnell Douglas developed the ATR, Automatic Thrust Restoration System, which had a more sensitive activation threshold, detecting differences as small as 7%. The ATR system did not analyze which engine had failed. It simply pushed both throttle levers forward, assuming that only the operational engine would respond. It stopped increasing thrust upon reaching the maximum go-around power and did not trigger any alarms or visual warnings. The only way to override it was to completely disconnect the auto-throttle system. "41 seconds later, the left engine, now running at maximum power due to the ATR system, also began to fail, spewing flames. The loss of thrust was significant, and the tension in the cockpit escalated dramatically. Seconds later, with the aircraft now at 3,000 feet, the right engine suffered a catastrophic failure and started ejecting burning debris over the Swedish forests. Before the pilots had time to react, the left engine followed suit, leaving the aircraft with no thrust at all. As a result, the generators began shutting down. The aircraft started losing electrical power, and the pilot's primary displays went dark. Their maximum altitude reached 3,318 feet before the powerless aircraft began an inevitable descent. Among the 123 passengers aboard Flight 751 were at least 2 Scandinavian Airlines captains. One of them, 47-year-old Per Holmberg, realized the crew desperately needed help. An experienced pilot who had been flying since he was 17, Holmberg had logged 920 hours on the MD-81, more than any of the flight crew members. Through the open cockpit door, he could see that the situation was out of control. At that moment, he decided it was time to step in. The captain still did not fully understand what was happening and shouted, "Start the engines! Start the engines!" Meanwhile, First Officer Cedermark contacted the airport controller, requesting urgent vectors for an immediate return. At that moment, Captain Holmberg entered the cockpit. First Officer Cedermark immediately handed him an emergency checklist and instructed him to start the auxiliary power unit, which would provide backup electrical power. Holmberg complied, but his immediate concern was keeping the aircraft flying straight and level to avoid losing control of the powerless plane. He urged the captain to forget about everything else and just look ahead. "Yes," responded Captain Rasmussen, who was now hand-flying what had essentially become a massive glider. The pilots began working through the engine restart checklist for the right engine, repeatedly attempting to bring it back to life. However, the damage was too severe, making recovery impossible. Given the fire warning, it was evident that the left engine was in the same condition.
We can't hold 2,000 feet. We're descending. We're now at 1,600 and still going down.
First Officer Cedermark reported to Air Traffic Control.
Prepare for an emergency landing,
Captain Rasmussen shouted to the cabin crew. The flight attendants rushed to prepare the cabin for an imminent crash landing. Returning to the airport was impossible at such a low altitude. Their only hope was to find a suitable place to bring the aircraft down. Captain Holmberg deployed full flaps as they dropped to just 900 feet, approximately 275 meters above the ground. As they finally emerged from the clouds, their limited options became painfully clear. Below them lay dense snow-covered forests, scattered houses, and a few buildings. Captain Rasmussen spotted a large field to the right but quickly judged it to be out of reach. Instead, he chose a smaller field almost directly ahead. However, Holmberg realized that if they continued straight, they might crash into the houses near the field. He ordered the captain at the controls to aim for the more distant field on the right. Rasmussen adjusted the heading by 25 degrees to the right, aligning the aircraft with the open field while avoiding the houses. In the background, a flight attendant's voice rang out. "Fasten your seatbelts. Stay calm." The cockpit filled with the blaring sound of low-speed warnings. "Should we lower the landing gear?" "Yes. Lower it. Lower it." Just a second after the landing gear fully extended, it began striking the treetops. First Officer Cedermark made one final, emotionless transmission.
Stockholm, SK751, we're going to crash right now.
Just before reaching the field that Rasmussen and Holmberg had chosen, Flight 751 descended into a dense forest of pine trees. The trees struck the fuselage and tore off the right wing, spilling fuel over the snow. The aircraft began to roll onto its right side, but before it could tilt beyond 20 degrees, it slammed violently into the frozen ground. The front section took the brunt of the impact. The plane skidded across the snow and ice, breaking into 3 pieces. Moments later, the MD-81 came to a sudden stop, shattered, missing a wing, and torn apart. The first few seconds after the crash seemed like the prelude to a major catastrophe. Silence, no movement. Until, one by one, the passengers began to emerge through the gaping holes in the fuselage. Incredibly, not a single person lost their life in this astonishing emergency landing. However, several people sustained serious injuries, particularly those seated on the front right side, which suffered the hardest impact against the ground. Per Holmberg, who had been standing at the moment of impact, had managed to brace himself against a bulkhead, but he was knocked unconscious when he was thrown headfirst into it during the crash. The pilots found him lying motionless on the floor at the rear of the cockpit. Captain Rasmussen carried him out of the wreckage and placed him on an emergency slide, where he regained consciousness about 20 minutes after the crash. What had happened? How did the ground crew responsible for de-icing the plane fail to notice the thick layer of clear ice covering the wings? Immediately after the crash, air traffic controllers alerted emergency services about the aircraft's disappearance. However, its exact location remained unknown until about 15 minutes later, when a survivor managed to make a phone call from a nearby public telephone booth. Rescue teams arrived at the crash site with helicopters and ambulances. They began triaging the injured and airlifting several of the most seriously wounded passengers to nearby hospitals. Although some individuals suffered life-altering injuries, the fact that every person on board had survived fascinated the media. The 3 pilots quickly became famous, and Swedish news outlets dubbed the incident the Miracle of Gottröra, named after a nearby village. Since then, the crash has been known by that name. The responsibility of investigating the near disaster outside Stockholm fell to the Swedish Accident Investigation Authority, SHK. Early in the investigation, it was determined that Flight 751 had lost both engines due to ice ingestion. The fan blades showed damage consistent with ice impact, and passengers recalled seeing ice breaking off the wings during takeoff. More than 500 engine fragments were recovered along the plane's flight path, yet they accounted for only about 30% of the missing material, underscoring the catastrophic nature of the engine's final disintegration. However, investigators needed to determine whether the failure of both engines could have been prevented. After all, an engine surge is not typically a fatal event. Even with damaged fan blades, an engine can continue running if power is reduced below the surge threshold quickly enough. The exact surge threshold of the right engine was unknown, but flight data showed that Captain Rasmussen only reduced power by 10% and did not decrease it further, despite the fact that the engine surge checklist required throttling back to idle. When asked why, Captain Rasmussen gave a clear answer. He had never received training on how to react to an engine surge. Unlike a total engine failure, responding to an engine surge was not practiced during SS training, nor was it required to be. While the steps were described in the Quick Reference Handbook for Abnormal Procedures, the pilots had no time to consult it. This highlighted the urgent need to make the response to an engine surge a memory item, a procedure that pilots must memorize and execute immediately, without referring to a checklist. Only after a detailed analysis of the flight data and consultations with McDonnell Douglas did investigators discover that the sequence of events leading to the crash was heavily influenced by a little-known system, Automatic Thrust Restoration, ATR. At the time of the accident, this system was so obscure that it didn't even have an official name. In fact, it was only named ATR because of its crucial role in the crash of Flight 751. The ATR system had existed since 1983, but its mention in McDonnell Douglas's official flight manual was limited to the section on noise reduction procedures. Although Scandinavian Airlines, SAS, did not apply such procedures, the ATR system was installed in all MD-80 series aircraft manufactured after that year, regardless of which airline received them. As a result, the accident aircraft, an MD-81 named Dana Viking, already had the ATR system installed when it was delivered new to SAS in early 1991. In fact, the crew of Flight 751 was completely unaware of the system's existence until the investigation revealed its impact on the crash. The critical question: why was the aircraft allowed to take off with clear ice on its wings? In theory, Captain Rasmussen was ultimately responsible for ensuring that the aircraft was free of ice before takeoff. However, in practice, this responsibility often comes down to verbal confirmation from the de-icing technician stating that all ice has been removed. Unless ice is clearly visible from the cockpit, pilots are likely to trust the technician's word. In reality, Flight 751's departure with ice on its wings was the result of a failure in Scandinavian Airlines' de-icing procedures. Technicians were not only supposed to look, but also physically check the wings by touch to detect clear ice, which is difficult to see. This deficiency in SAS procedures was particularly concerning given that clear ice on MD-80 series aircraft was already a known hazard in the aviation industry. In fact, since the launch of the DC-951, there had been documented cases of clear ice breaking off the wings and being ingested by the engines. Ultimately, the Swedish Accident Investigation Authority, SHK, concluded that the accident was caused by multiple systemic and operational failures, including deficient ground crew procedures at SAS, inadequate pilot training at SAS, poor design and documentation of the ATR system by McDonnell Douglas. As a result of these findings, the SHK issued 15 safety recommendations, including that McDonnell Douglas provide airlines with a way to disable the ATR system, that upper compartment impact resistance requirements be improved, that the Swedish Civil Aviation Administration ensure SAS improve its quality assurance program. Thanks to these measures, and to the decision-making of the 3 pilots under immense pressure, the aviation industry learned about the dangers of ice ingestion in MD-80 aircraft without any loss of life. Unfortunately, Captain Rasmussen never got to experience these changes firsthand. Although many survivors consider him a hero, he suffered severe emotional trauma from the accident, which left him unable to return to the cockpit. He never flew passenger aircraft again,